Mr. Zuckerberg, would you be comfortable sharing with us the name of the hotel you stayed in last night?
Um, no.
User privacy. It's something that we value in our everyday lives, but we see that it's being violated over and over again by social media companies, three-letter agencies, employers, hackers, and service providers. In an era of mass surveillance, there seems to be nowhere to hide and nowhere to stay anonymous from these threat actors. I'll be covering what are the current threats that we face today in regards to user privacy and staying private online, and what current mitigation strategies do we have against these threats. So, when anyone makes a first move into trying to stay more secure online, their first thought is likely going to try using a VPN. A VPN is a service that conceals your IP address by the VPN server connecting to the destination server or the server you want to connect to. It then forwards whatever traffic that comes its way from your device to the destination server. So essentially, what happens here is that the VPN server acts as a middleman between you and the server. So all the server sees is just the communication going on between the VPN server and itself. All of the traffic between the links here are encrypted, so they cannot be seen by anyone except by the sender and the receiver. And I know you're thinking, oh well, that looks pretty safe to me. It looks like, nothing could go wrong here. But the whole kind of flaw with this, or the whole problem with this, is that you never know if the VPN service provider is logging your data or not. Let me give you an example of this. Let's say that law enforcement suspects a particular IP address belonging to a VPN has been suspected for criminal activity. Law enforcement will then ask the VPN service provider for the actual IP address associated with the VPN IP address, and then the attacker, the user, might be arrested for this. And in countries like America, you have the Patriot Act. So, under the Patriot Act, a VPN service provider can be forced to collaborate with law enforcement to unmask the identity of someone using the VPN service. So essentially, you can't really even know when a VPN service says that they have a no log policy. You're essentially just you're putting your bets on how much you can trust the VPN service provider, and even though like the protocol is secure on itself, it's you're using encryption between all of the different links. The VPN server is acting like a middleman, um, and but you can never really trust the VPN service provider to do anything for you. If you're a bit more advanced in your methodologies to stay anonymous or have your data secured, you may have come across Tor. Tor is an open source and free software that's used for anonymous communication. Tor stands for the Onion Routing Protocol, and it was initially developed by the US military, also known as DARPA. Tor works by routing your traffic through a series of nodes in the process of what's called the Onion Routing Protocol. When you first connect to the Tor network, your traffic enters the network through an entry node. Your data is encrypted in different layers which resemble an onion. In each layer of the encryption, it corresponds to a relay node. As the data passes through the various nodes, each layer sequentially gets peeled off, which reveals the address of the next node inside the circuit. This layered encryption helps in staying anonymous. The middle nodes do not know the original source or the final destination of the data. Once the data reaches the end node, or what's called the exit node, the last layer of encryption is reached and the destination is then revealed, in which the packet is then sent to the end destination. The website only sees the exit node's IP address and not the original address. Overall, as you can see, Tor in theory provides a good level of anonymity by scrambling your traffic through a series of nodes, making it difficult to find the source or end destination of a given packet. However, Tor networks are subject to what are called Sybil attacks, which in this case, an attacker hosts a number of Tor network nodes, which could include guard nodes, or middle nodes, or exit nodes. The attacker can then perform network analysis on these nodes in an attempt to unveil the identity of who's sending the traffic and who's receiving it. This is why it's so important to verify the authenticity of your Tor network, in which you can do by looking up the history of the IP address. So, as you can see, we have an open window of the Tor browser. Now, a good thing to know about Tor is that you can check, if I type in here, let's say google.com, we'll just wait for that to load up. Oops, Google doesn't like that. Let's, I don't know, which website should we go to? bbc.com. Alright, let's try that. So, as you can see, we've connected to the BBC website. And a handy thing to note here is that you can check your like what connections that you have to each node on the Tor circuit. So as you can see, we have our browser here, and then we have a bridge, then we have Bulgaria, Germany. We basically have servers in different regions across the world. So that's a good thing to note. We can create like another circuit, so we can go and do a new circuit for the website, and bam. So we've just rotated around the different kind of networks. So a handy or a useful tip to know here is that you see the way all of these IP addresses or all of these different servers have a particular IP addresses associated with them. You can go on a website called Tor Project Metrics, and you can basically search all of these different relays inside of this little tool here. So as you can see, the relay search tool displays data about single relays and bridges in the Tor network. Provides information how it can be configured along with graphs and their paths. So we'll go ahead and we'll do that. I'm going to be copying the IP address of Finland. So it's basically like the middle node in between all of these. So you've got your guard node here, got your exit node here. Right in the middle is Finland. We'll go ahead and we'll paste it inside here. And now we have a bunch of different statistics on this relay node here. So, we can check its nickname, we can check its OR addresses. Actually, what are these? So these are addresses and ports where the relay listens for incoming connections between clients and different and other relays. And as you can see, we have a bunch of other different metrics. And a handy thing to note here is there's a validity check here. So this is probably really important if you want to stay secure and anonymous. You want to make sure that all of these nodes are validated, because what ends up happening is if you connect to a malicious node, it might not have this validity check or anything like that. Um, like for example, if it looks like it's a it glows. If it smells like it glows, then don't use it. Go over to the Tor circuit here and create a new circuit. Click that button if you notice anything suspicious inside of the Tor metrics here. And we got a bunch of other stats. And yeah, that's pretty much how you go ahead and you verify all of these different kind of nodes. I hope you aren't using any of the services I just mentioned on a Windows operating system. So the whole problem with Windows is it sends telemetry data to Microsoft servers by default, which can de-anonymize you as soon as you log into your PC. Obviously, this isn't ideal, and you may use a despooking tool, which gets rid of any telemetry services that are hosted on Windows. You can find a bunch of those on GitHub, or you can search up some YouTube tutorial to manually despook it. But however, I just don't think it's an ideal approach in terms of going into your operating system and trying to manually do everything. In my opinion, it's better to take a zero trust policy on any proprietary software. So this can include Mac, Apple, anything that's that the code isn't available for you to see. And even on some Linux distros like Ubuntu, um, I there's Canonical, which can also send telemetry data to the servers and could potentially be used to de-anonymize you. So it's better to use an operating system which is open source and it's designed for privacy, so you can validate the code yourself, or other people will just come across the code and check it for you. So one such operating system you can use, it's called Tails, and you can host it on a bootable USB. And the advantages this has is that your the operating system is hosted on a live image, which means that um, there's no data that's stored once you log in and you log out. All the data is gone from your device. So you can do your top secret NSA stuff and not get caught pretty easily, because everything just gets wiped from RAM once you restart your PC. Um, so yeah, it's extremely handy to use Tails. Another operating system which you can use is Vonix, and it works like Tails except it has persistence enabled. So you might be thinking you've taken all of the countermeasures in being tracked and you think you're relatively safe, having known all of the risks. But there is one glaring issue in almost any modern day computer now. If you're using a computer that has the Intel microchip, it contains a separate microprocessor known as the Intel Management Engine, or ME. It operates independently from the main CPU, and since this processor is separate from the CPU, it has its own power supply sent to it, which means that it will continue functioning regardless of it being switched on or off, as long as it has a power supply attached to it. Intel's management engine, or ME, can bypass firewall rules. See, any data passing through the CPU or RAM, shut down the machine, bypass any encryption, record any keystrokes and mouse movements, and also view what is displayed on the screen. So, if an attacker were to find an exploit on this device, they could use this to their advantage. And you already have to assume there is an exploit for this, since it is proprietary software, meaning the code, you can see the code associated with it. And there has been exploits developed for this. There's a video done by Black Hat in which they have developed an exploit for Intel's management engine. I'll leave the link down in the description if you want to check that video out. It's a very good watch. I recommend it. And you can probably assume that if a bunch of hackers have already done this, then it's very likely that those three-letter agencies definitely have their hands on something similar to this. Some possible solutions to this can include buying a Libre boot laptop or PC, which has most of Intel management engine's capabilities disabled, or you can buy a computer before 2006, which didn't have Intel management engine on the machine. And if you're thinking, oh well, fuck Intel, I'm not gonna go anywhere near this. AMD have their own version of this, and it's known as the AMD Secure Processor. So you're pretty much screwed on all angles. Your only main choices are to buy an old laptop or buy a Libre boot PC. So with all of that out of the way, we can summarize this entire video by saying that your OPSEC, or your operational security, it's only as strong as your weakest point. A chain is only as strong as its weakest link. And in terms of OPSEC, it's good to trust absolutely no one and nothing. A stage 3 schizophrenia mindset is recommended when doing anything you don't want someone else to see, especially three-letter agencies. Thank you so much for watching this guide. I hope you liked it, and please join my Discord server in the link below. I'll have you can contact me there, and you can ask me questions about anything. I'm always looking to learn how to make my content better for you guys. So peace out, and I'll see you in the next one. Thanks.